Hi, everybody. Thanks for joining me today. Today, I'm going to be talking about new Amazon EC2 instances that feature the AMD EPYC processors. My name is Alex Bastavros, and I'm a Senior Product Manager in EC2. So we're going to give a quick overview of Amazon EC2. Then we're going to dive a little bit into our core platforms within EC2. Then we're going to talk specifically about the new instance types that feature the AMD EPYC processor, specifically in our general purpose families and memory optimized families. Then we'll dig into some of the use cases and workloads. So first off, across Amazon EC2, this business encompasses a broad set of services and payment options for customers. Just giving a quick summary, within the resources, you have a variety of instance types. And when I say instance types, what I'm referring to is a virtualized machine that you would run on top of the host servers that AWS provides. Along with that, you have various storage options and network connectivity options. The availability part of EC2 encompasses the regions and availability zones where these various instances are available. Also, different ways of launching your instances, whether it be in placement groups or other. We also have a bunch of services that help you do load balancing and auto scaling as your needs and infrastructure grow. Then we have a whole bunch of management services. These are the services that we would provide to help you do your deployment, all your monitoring and administration as your infrastructure needs grow as well. And then purchase options. We have various purchase options that we'll talk about here before getting into some of the deeper dive EC2 instance types. So first off, if you think about what the physical servers that we host in our global regions and how we virtualize those into an instance type. So on the left side of the screen, you can see these different racks that we would actually have physically located in our 21 regions globally. On top of that, we have a whole bunch of specialty software that we design called a hypervisor that will sit on top of the host server and allow you to launch an instance. So this is really interesting for customers who may not want to launch an instance the full size of a box, which we call bare metal. With virtualization, you could actually launch a slice of that box and only pay for a slice of that box. So this makes it super effective as you're launching a variety of different applications, some that may not require a full host server and some that may require the entire box itself. So going back to some of the roots of EC2, the premise of this business we talk about is about the ability to scale up or down quickly or as needed. So EC2 does stand for Elastic Compute Cloud. So having the ability to elastically scale up and then reduce that footprint down as needed is one of the key value props of EC2. We also work super hard in how we design and price our instances to make sure you only pay for what you use. And then back in 13 years ago, we have the M1 instance type. So this instance type was designed in a multi-purpose fashion to fit all workloads. But over time, we've learned that the needs of customers based on the variety of applications that have now migrated to the cloud, as well as direct feedback from customers that one instance type doesn't actually fit all the needs. So we have a continued rapid pace of innovation. Going back to the initial M1 instance type, we have iterated very quickly over the past 11 years to offer over now 190 different instances. So this would encompass different sizes and different features that you can pick to optimize your workload. And today we're going to talk about a few of these to help provide more options, specifically around some of the areas where you can actually save cost. Within EC2, we do talk about three different major pillars. So first is the category. So these are the different classifications of the instance types. So we talk about general purpose. General purpose is typically a great place to get started in the cloud. If you want to initially deploy from an on-premise to a cloud environment, it typically is a good place to get started. We have burstable instances that optimize your cost by reducing how much available CPU is available to you. Compute intensive, these are designed to be the highest performance compute instances available. Memory intensive, which is self-explanatory, where you get more memory for the workloads that you're running. Storage, dense storage, and then a whole bunch of different graphics and GPU options as well. Within each of these categories, we're starting to broaden the amount of capabilities. So first one here, which is one of the primary topics of this talk, is going to be your choice of processor. We have a very broad offering that leverages the Intel scalable Xeon processors. And at the end of last year, we started offering processors now built by AWS with our Graviton processors and our A1 instance type, and our AMD instances, which leverage AMD's EPYC processors. So capabilities are fast processors. So we now offer processors up to 4 gigahertz on our Z1D instance family. We have our high memory instances that can offer up to 12 terabytes of memory. Different instance storage options with spinning drives and then high-speed NVMe connected SSDs. Accelerated computing, so this is the FPGAs or GPU instances, or the ability to actually add GPUs to your instance type. And networking capabilities. We did launch at reInvent in 2018 the ability for an instance type to have up to 100 gigabits per second networking bandwidth. We also now offer bare metal sizes. So this is what I was referring to earlier. If you do want a full physical server like you would have it in your own data center, we now have that option, removing the hypervisor from your instance. And then sizes, all the way from the smallest instance size, which we call Nano, which offers 2 vCPUs and half a gig of memory, all the way up to 32x large. And then within those, you have different options. So we have our EBS, or elastic block storage, which is where you could provision and choose a size of your storage drive that you would connect to your instance type, which has a whole bunch of really great features for security, snapshotting, backup, right sizing, which is really flexible. You can add to any instance type. The elastic graphics, which you can add to your instance type as an option, as I was referring to earlier. And then elastic inference, which we also talked about at reInvent in 2018. So put all this together, you really have a broad variety, over 190 instance types, and then different capabilities and options to optimize that situation for your specific workload. So how do we do this in AWS? We've been investing in what we call the AWS Nitro System. And what this is a collection of parts and software that we bring together to enable a lot of flexibility on the platform. So this is combined our Nitro card. So this provides connectivity to local NVMe storage drives on the instances that offer that. It provides the connectivity to our block storage, or EBS, and our networking, monitoring, and security. We also have the Nitro security chip. This integrates into the motherboard and protects all the hardware resources in a multi-tenant environment. And then our Nitro hypervisor. So this is really the secret sauce of AWS, where we created a very lightweight hypervisor, and that offers the majority and like bare metal performance of the memory and CPU to your instance. So bring all these pieces together. These really are the building blocks that allows us to rapidly design and deliver Amazon EC2 instances. So for these different characteristics, I wanted to talk a little bit about the naming convention, just to familiarize the audience on how we do label and control all these different features. So when you're going through the selection process, this is slightly more familiar. So some of the key categories that we do talk about, which is the amount of CPU the amount of memory, the amount of storage, and then the network performance. So the first character is the instance family. So this is across all the different categories I covered in the previous slide. Here we're talking about M. So M stands for our multi-purpose family. We similarly have a C, which is your compute optimized, or R, which would be your for RAM or your memory optimized system. And then the following character indicates the generation. So the higher this number, it'll indicate the latest generation of instance. So if you're going to just get started in EC2 and you're new to AWS EC2 in the cloud, you're typically recommended to look at the highest available number for that specific family that you're interested in. So in this case, if you're interested in a multi-purpose or what we might call general purpose instance type, 5 is the latest generation of that instance type. So that's where you'd want to start looking at the different options in that family that meet your workload's characteristic needs. And then there's subscript letters, which talk about some of the additional capabilities. So the A here specifically talks about our AMD version of that family. So M5a is a multi-purpose family. It's the 5th generation, which in this case, it's the latest at this time. And then additional capabilities, which A stands for AMD version of that family, where we already have an M5 without the A, which would indicate the Intel Xeon scalable processor version of the M5 family. And then following that, we have a size designation, so the instance size. So extra large stands for the size or how many vCPUs you would get for that size. So one of the key topics is going to be, for this presentation, is going to be the choice of processors and architectures. So we have a very broad offering of instance types that leverage Intel Xeon scalable processors. And until the end of last year, that was the dominant option within our portfolio for customers. Now, customers tell us that they were looking for some various options around different cost points or different instance features. And we were able to bring in, leveraging the AWS Nitro System, an AMD EPYC processor, as well as an AWS Graviton processor, which is based on a 64-bit ARM architecture. So between these 3 different processor types and a lot of the other capabilities I talked about, it gives you the opportunity to right size and choose the right compute you need for each application and each workload that you would want to run on the AWS cloud. So let's dive a little deeper into the AMD EPYC processor instance types, which is the topic of this specific session. So within our core platform families, so these are the 3 large pillars of EC2 Core Platforms. So compute optimized. So this is where you're going to get the highest CPU performance. So if you need the highest single threaded, or you find that your workload is always pinging the CPU to close to 100%, this is typically an area where you would want to evaluate an instance type for the highest CPU performance. General purpose category. This is where you get a balance of the CPU performance. You'll get a balance of memory as well as network. And then memory optimized. This is where you get the highest vCPU to memory ratios in the EC2 family. So where we've launched AMD EPYC in our first wave is across our general purpose. So specifically our M5 family and our T3 family. So this is our general purpose and our burstable instance types, as well as on our memory optimized family. So some of the features of these new AMD EPYC instances that we launched. So first off, we've been partnering with AMD to work on a custom AMD EPYC processor that runs at 2.5 gigahertz all-core turbo in their 7000 series AMD EPYC family. We offered the same virtualized instance sizes as M5, R5, and T3, which were already existing families when we launched the AMD versions of those families. For customers, as we covered in this deck already, there is a large amount of instance choices, over 190. We didn't want to add to the complication and say, if you wanted to pick an AMD version of that instance type, now you have to go reevaluate how many vCPUs you would need, how much memory you would need, how much networking you would need. So what we did here was offer the same instance sizes between the two families, making the decision slightly easier as you start evaluating different compute options. These are powered by the AWS Nitro System. This is one of the ways that we've been able to create a very familiar platform. So if you're running on our 5th generation instances today, you're going to see a very similar experience around ENA or enhanced networking adapter, NVMe drivers to connect to EBS or local storage, for example. And then connectivity. So support for networking and EBS burst. So this creates a lot of value for customers who want to use more networking and more EBS connectivity, but not necessarily more vCPUs or memory. So we did launch the AMD EPYC instances. We now have them live in 5 regions across the US East, US West, Europe, and Asia Pacific. So what are some of the benefits of leveraging an AMD EPYC instance type? So first and foremost, when we talk to customers about moving to the cloud for the first time, or customers that are already in the cloud, typically once they get a little more familiar with their workload and they've been running in the cloud for some time, or they are on-prem and they're looking for ways to reduce their costs, price always comes into the discussion. So with AMD EPYC, one of the key benefits that we've provided with these instance families is 10% lower prices than the M5, R5, and T3 families, respectively. So if you choose the A version of those instance types, you can actually save 10% on your costs. Secondly is the processor choice. So offering customers the choice of using an AMD EPYC or Intel Xeon processor. Previously, as I mentioned, you may only have the option to use an Intel Xeon scalable processor. Now you can actually pick an AMD EPYC version of that as well. And these are application compatible. So AMD leverages the same x86-64 instruction set that you would see with the familiar Intel offerings for the instance types. So this makes, between the application and instance size capability, it makes it very easy to migrate between the two. So you can find the perfect mix of instances to optimize your costs. So talking about some of the families that we now offer with AMD EPYC. So the first one is the general purpose instance types, or the M5 family. So M5 stands for multi-purpose, and the M5a and M5ad instances are the overarching brands of those family. So these are general purpose instances. What we do is we talk about general purpose really offering you a balance. It's really the easy place to get started in the cloud. So for each vCPU you're going to get 4 gigabytes of memory. That's one of the key characteristics of our general purpose M families. These leverage the 2.5 gigahertz AMD EPYC 7000 series CPU that's custom for our AWS AMD EPYC instance types. You're going to get up to 20 gigabits per second in networking bandwidth. And then these are going to be the 10% lower prices than our M5 instance types. And then we recently announced back in March of 2019 that these are also offering up to 3.6 terabytes of NVMe attached SSDs. So for the use cases where you do need local storage for very low latency or very high performance storage for data logging or scratch space, that's now an additional option, as you can see denoted by the D, which stands for disk. These instances are available in 6 sizes. So it starts with large, where you're going to get 2 vCPUs. And because you get 4 gigabytes of memory for every vCPU, you'll have 8 gigabytes of memory total for that instance size, all the way up to 96 vCPUs or 384 gigabytes of memory on the M5a or M5ad 24x large. So this is where, as I mentioned, you want to really get started in the cloud, or you're not sure what instance type you need. M5 is a perfect place to start. You can look at these in production for things like web apps and servers, your enterprise applications, or your dev and test environments. So looking at our M5 instance family, I wanted to talk a little bit about how this family has evolved since our initial launch. So in 2017, we launched the M5 instances. M5 provided up to 20% better price performance than the previous generation M4 instance types. We offered with M5 a new 24x large size, which enabled up to 96 vCPUs and 384 gigabytes of memory. And this was the second instance family following our C5 instance types, which is our compute optimized instance types, that is built on the AWS Nitro System. In 2018, we followed up with our M5d instances. So these are the Intel Scalable Processor versions of M5 with D. So we added the high-speed local NVMe connected SSDs to our M5. And then later in the year in 2018, we launched the M5a instances. So this was an additional option where we're able to provide the AMD EPYC processor and provide 10% lower cost. And then earlier this year, we launched the M5ad instances. So this adds local high-speed NVMe connected SSDs to the AMD EPYC version of M5. So altogether, even within our M5 family or general purpose family, you have 26 different instance choices, providing you the ultimate flexibility around performance and cost. Another key point I wanted to emphasize is the size mapping. So when I mentioned earlier that we offer the same virtualized size, what that means is for every model, in this case from M5 large, extra large, 2x large, all the way to 24 extra large, you can see between the AMD version and the Intel Scalable version, you're going to have the same number of vCPUs and memory. So this one-to-one mapping of instance sizes makes it very easy for your selection process, especially if you're already using M5, or if you're using a previous generation like M4 and you migrate to M5a, you also have the flexibility to move to M5. So this one-to-one mapping is designed to make it very easy as you migrate to our latest generation instance types. So now I wanted to talk a little bit about our general purpose applications. So the M5a that we discussed, or the M5 instances, typically are the best suited for when you have continuous fixed CPU usage. So you can see the graph here on the left-hand side. This shows the CPU utilization as a function of time. So typically you're able to get really good utilization. You have a workload that's constantly running, and you would use an M5, which gives you fixed CPU resources. On the other side, we actually see that the majority of the general purpose applications have a lot of variable peaks in CPU usage. Maybe different times of the day, your customers are leveraging whatever application you're running. And you can see here, you might have a very, very spiky type of workload where your CPU utilization can be under, close to 0 for a period of time, and then spike all the way up to 100% while it's running some job, and then all the way back down. So in this case, your average CPU can be much, much lower than what you're allocated, or than what you need, I should say. So for this situation, what we did is we looked at a Burstable T family. So T are our burstable instances, and these are optimized for a lot of general purpose workloads that only need occasional high CPU use. While we offer them at a lower price point and with a certain amount of average CPU available to you, you can sustain high levels of CPU indefinitely if your application needs it. That's one of the key benefits when you look at our T3 and T3a families. So you get some moderate CPU usage included. So each size that you pick, the larger the size, the more CPU usage is included in that offering. And then you pay for sustained high CPU usage. So any additional CPU usage over the level that is offered to you with that specific instance size, you would treat that as a pay-as-you-go model. So this is very, very, very cost effective if you do have a very spiky workload. Now let's talk about our T3a, Burstable General Purpose Instances. So these burstable instances were launched in April 2019 to full general availability, and they offer a baseline level of compute. These leverage the same 2.5 gigahertz AMD EPYC 7000 series CPU that we leverage on our M5a and R5a families. They have unlimited CPU burst setting by default, which means that even if you go above your allocated CPU credits, you're not going to get throttled. And we'll talk a little bit about how that works economically on the next slide. These T3a instances are priced 10% lower than T3 and start at only 0.0047, which is less than half of a penny per hour, making it very cost effective for workloads that don't need high sustained compute. T3a comes in 7 sizes, similar to our T3 family. They range from 2 vCPUs with half a gigabyte of memory all the way up to 8 vCPUs and 32 gigabytes of memory. Where we see customers leveraging these instance types are typically for microservices, virtual desktops, and code repositories. So let's look at an example of when it is lower cost to use T3a. Typically, the T3a family or T3 family and the M5 and M5a families can be used interchangeably depending on how your workload CPU utilization is set. So in this example, you can see that this workload is a very spiky workload. It has some characteristics where it'll go above. For this specific T3a large, you get a baseline of 30% of your CPU utilization. So if you go, for example, in CloudWatch, which is an AWS utility that allows you to monitor your instance types, if your baseline average CPU utilization is at 30% or lower, that's going to be what you're allocated for that size. In this case, you can see for some period of time, T3a large in this workload is below 30%. Sometimes it's above, sometimes it's below, and then sometimes it goes above, and so on. So if your average CPU is below 30%, you're going to be very happy, right? You save money. It's a lower cost option. You don't actually notice any difference because your average is already below 30%. If you look about where you break even, so if you go above 30% on average, you're now going to have to purchase credits, CPU credits. So as your CPU usage increases, your break-even point, typically we talk about break-even as when does the T3a large become the same price as an M5a large. For the case of T3a and M5a, that would be roughly 41.2%. So if you're operating within 41.2 or lower on average CPU utilization, you're typically pretty happy. Either you're saving money or you're not spending any more money than you would if you used an M5a large for this example. Now, if you go all the way up to the point where you see 100% CPU utilization, you can get to the point where you have to purchase so many credits to get above what you're allocated for T3a large being 30%. If you need to get to 100% and you're running that 24/7, the amount of credits you would have to purchase actually makes the cost of running T3a large more expensive. So for that orange line where you're running at 100% CPU utilization, T3a large with all the additional credits you're going to have to purchase would actually be 1.7 times more expensive than an M5a large. So in that case, you're actually quite sad because now you're losing money and you should be using an M5a large. So choosing between our general purpose instances. So T3, T3a, which we just covered. So these are optimized for a lot of workloads that really only need occasional high CPU usage. And in that family, we also have Intel and AMD EPYC options. M5, M5a, this is where you get a balance of compute, memory, and network with fixed CPU resources so you can burst 100% of the time. This is where you also have an AMD and Intel version. And then workloads that can scale out across multiple cores that fit within the memory can run on ARM should be leveraging our A1 instances as another option to evaluate. So the last family with AMD EPYC, I want to talk about our R5a and R5ad. So these are memory optimized instances. So memory optimized are actually going to be very similar to what we offer with our M5a and M5ad general purpose families, but these will give you 2 times the memory for every vCPU. So in this case, you're getting 8 gigabytes of memory for every vCPU that you would allocate to your size. So we have 6 sizes if you look on the right-hand side of the screen, from 2 vCPUs, which offers you 16 gigabytes of memory, all the way up to 96 vCPUs, which would give you 768 gigabytes of memory. Otherwise, you're going to see a lot of the same characteristics. You're going to have 2.5 gigahertz AMD EPYC CPU. You're going to have up to 20 gigabits of networking bandwidth. And then R5a will be priced 10% lower than our R5 instance types. And similarly to M5 and M5ad, we now offered an R5ad family, which brings in 3.6 terabytes of NVMe attached SSDs. This has been very popular for this R5 family, as you see people leverage the high memory availability, the high-speed NVMe attached SSDs for a multi-tiered caching system for the highest speed when you're operating on data or doing your data logging. So R5 and R5ad, some of the use cases you should leverage these for are going to be in-memory caches. So this is where you want to store a lot of your information within the memory for very, very quick high-speed access. High-performance databases that can leverage the memory and the NVMe disk in a tiered data structure. And then our big data analytics with a similar benefit, leveraging the memory for very high-speed access to the data and high-speed operations on that data. So across our AWS global infrastructure, we have 21 geographic regions and 64 availability zones. Currently, we have AMD EPYC available in 8 regions globally, with a lot more regions coming soon. So looking at the experience, so we talked about all these options for instance types. I wanted to show you, if you go to the Amazon EC2 console, and you would select down from the drop-down menu of all the different instance types when you're picking your infrastructure to run, you can see here at the top that's highlighted the M5a large all the way down to M5a 24x large. They followed by the M5d large to 24x large and M5 large to M5 24x large. So the only difference you would do here is you would select the one that has an A on it. And you can see a lot of the other specifications, from the number of vCPUs, the amount of memory, the support for EBS, for example, are going to be very similar as you evaluate this instance type. Similarly, from an AWS CLI, the only thing that you would change is add the character A. So it's highlighted in orange what that instance name is. It's the same size. For example, if you were running an M5 4x large, you would now make it an M5a 4x large. So there's really nothing else you have to do to select this. It's really just like any other instance type. The difference here is you're actually going to see very similar instance sizes between the non-A version and then the A version. A version being the version with AMD EPYC. So let's talk through a couple customer scenarios where we've seen AMD EPYC be very successful. So the first customer is customer A. So this customer is running a customer service front end where they had a call center taking calls from customers, and they would log data back and forth to a database. So they run their workload leveraging our ECS service, which is Elastic Container Service, running a bunch of microservices. And what they found was their workloads were largely I/O bound. They were typically waiting for transactions to a large database. This customer said, well, maybe we can save some money, especially because we know our CPU usage is not very high. And they were migrating from M4s to M5, M4s and M5s to M5a. So with the application compatibility, the migration took them very little time, in the matter of minutes and hours, and they saved over 10% in their infrastructure costs with no notable impact to performance. Our customer B, they were running a Java application server. So this was a business application that leveraged Java, and it was largely memory bound and was leaving the CPU idle a lot. So this customer heard about this new A version of our instance types, so specifically in this case R5a, and they found that once they migrated from R4 to R5, they were able to save more than 10% on their infrastructure costs, and they found no impact to their application performance and only a slightly higher CPU utilization, which was very acceptable for the tolerance that they had in their application. Another customer was running an Amazon Elasticache database, so a very memory-intensive workload. They needed over 1 terabyte of data to store the simulation results, and they needed very quick access to that data for feedback into their simulation modeling. So for them, it was all about the cost and the capacity of the memory. So they found that R5a fit perfectly as they offer 10% lower dollar per gigabyte compared to R5. The migration was easy, and there was no noticeable impact to their performance for this workload. Another customer we talked to was running the SAP NetWeaver Business Suite application. So it's an enterprise application. The benchmark that is used to measure the value of the instance is very CPU intensive, and this application does come with significant licensing cost. So what the customer noticed was in this specific benchmark for NetWeaver, they found that they were only able to achieve about 70% or so of the performance at 10% lower cost. And this customer was very sensitive to the amount of CPU performance available, and the 10% lower cost did not offset the performance differences for them. So it was not a good fit, and they decided to stay with M5. So when we think about how the new AMD EPYC instances fit into our family, we want you to think about a couple different cases. So first one is if you're currently on M3, M4, or T2, so some of the older generation EC2 instances, assuming you've been a customer of EC2, or if you're leveraging M5 and T3, so you've already moved to our latest generation instance types, but maybe you're not getting full optimization out of those and you find your CPU utilization is quite low. You can go and evaluate would an AMD EPYC version of these at a lower cost point, being 10% or even more than 10% coming from our M3, M4, and T2 families, be beneficial for you. It's a very easy evaluation process, having the same instance sizes and then having the same application support given the same x86 64 architecture. And a similar story with R5. If you're currently on R3 and R4, or you're using R5, specifically customers that that focus on how much money they spend for every gigabyte of memory because they find their workloads need the most amount of memory possible for the best price, an R5 and R5ad instance types can be a very interesting optimization for you. So to recap, AMD EPYC instances, so this is the new M5a, M5ad, R5a, R5ad, and T3, offer 10% lower prices. They increase the customer choice, giving you another lever to pull to optimize your balance between performance and cost. They're application compatible, making it super easy to migrate to and from. and they're available now. So these are available now in 8 regions, with more regions coming online soon. Thank you so much for joining me today. If you'd like to learn more about AMD EPYC EC2 instances, we have a link to a webpage here which talks about the AMD EPYC family, as well as updated constantly with new content and new customer stories. And if you have additional questions, feel free to reach us directly at ec2-amd-customerfeedback@amazon.com. Thank you so much.